Good morning, everybody, and welcome to day 2. Thank you for attending. So we're starting off a little bit on a lighter note today, and so there's very little sciencey things in my presentation. I'm more discussing methods and so on. So as Prof said, we're looking at the 3 T's, so trapping, tagging, and tracking, and then a little bit of additional information. Now, before I get going with the actual presentation, I just want to say that this shouldn't be considered as training, and the methods that we're describing here shouldn't just, if you're interested in working with bats or starting a project on bats, you shouldn't take the presentation, what I show you today, and just go out in the field and do it. With most of these things, you still need training, and there's still a lot of practice that needs to be done with everything. Okay, but let's dive in. So firstly, just with bat capture. Now, to capture bats allows us to gather samples, to collect samples, and this includes obviously the virological samples that we've been talking about quite a lot, but also then general ecological data, so age, measurements, and those type of things. Now, Dr. Epstein yesterday mentioned that trapping methods need to be safe and effective, and there's 3 general methods that's used, namely harp trapping, mist netting, and hand nets. And I'm going to run through all of these and give basics on them. There are other methods as well, but these are the 3 main ones that we use. Now, it's important to standardize your methods as far as possible, and this just means that if you start collecting bats or capturing bats, that you try and use the same methods for each of your projects. That being said, it's important to know that bats are quite clever, and something that we call trap shyness occurs. That just means that if you put traps or nets in the same location for a prolonged period, the bats actually get used to them and start avoiding them. So if you've got 3 nights of trapping, after a while you're going to see that your capture success starts diminishing slightly. If you do it on a monthly basis, it tends to be okay. Now, when you consider the method to use, it's firstly important to consider the species that you're targeting. For a lot of the work that we do, we don't actually go species specific, so we don't target trap. We kind of try and do it general, but if you are looking to capture specific species, it's important to have a look at the species, roosting behavior and the activity, and also the numbers present, because the method that you're going to use depends on the number of bats that are present. And then location. So for each location, you tend to use a different method. So first off, we've got mist netting. Now, mist netting is one of the more common methods to use. It's also very popular with bird research. So a lot of people would have seen these. I also want to apologize. I know a lot of people would have seen a lot of this presentation, but there are people in the audience who's never actually captured bats or worked on bats before. Now, the mist netting is effective on a wide variety of species, and it's one of the reasons why it's so common. It's also very simple. It's very easy to put up mist nets. And later on tonight, we're actually going to go out and pop up some mist nets and hopefully catch some bats. We did test last week, and yes, indeed, we did test this out last week, and we did capture a few bats, so hopefully tonight goes well. Now with mist nets, you get quite a variety of them, and the first thing that you need to consider is what's called the denier and the mesh size. Now, just generally speaking, this just refers to the thickness of the net and then the size of the mesh. And then this influences what species you'll catch. So we tend to use, for bats, a very thin net, thinner than what you use for birds. But this is now more for insectivorous bats. So if you look at the big flying foxes they capture, that's basically like a fishing net. It's massive, otherwise they're just going to fly straight through. Then you also get a variety of mist net lengths. And it varies basically from 3 meters to about 15 meters. You get larger ones as well. And the ones you use just depend on the area where you've got to place them in. It's always good to just have a few options available, so that when you get to a site that you don't know what to place, that you actually have some options. That you, if you're placing nets in a small gap, that you've got the 3 meter available. If you're going across a river or something, that you've got a 15 meter available. So you just have some room to play with. The heights of these nets are fairly standard, so it varies between 2.3 and 2.6 meters. But this you can vary as well. So I'm going to talk about stacking nets in that as well. As for open time, so in general, we open the nets either when we see the first bat flying or at sunset. The reason for this is just so that we can avoid capturing too many birds. Now, I know there are many bat biologists who also enjoy capturing a bird or two. Yes, Ara. So I also don't mind getting a bird in the hand. And then again, Dr. Epstein yesterday mentioned monitoring times. Now, if you look at textbooks, it'll tell you that it's fine. You can put up a mist net and leave it for about 20 minutes and check it just every now and again. I tend to disagree with this because the longer you leave a bat in a net, the more entangled it gets and the harder it is to remove. In addition, bats tend to chew through the nets, and once you've got holes in your net, the thing is useless and you can throw it away. So a little holy net, hole here and there, that's okay, but if you start capturing too many bats, it's in the net for too long, the net's going to be destroyed. And that's also why we don't use mist nets when you've got large numbers of bats present, because you've just got too many bats that goes into the net and it takes too long to get them out. So we never deploy mist nets at cave entrances. These are more used in general areas where you know bats are flying, but you suspect that you're not going to capture as many. And the last point I put in as a general, but also just a consideration for tonight. Mist netting works better when you don't have too many lights present. So when we're out at the nets tonight as well, please keep the lights to a minimum. We'll have a few people who's monitoring the nets and so on. As soon as we've got a bat, you're welcome to go a bit closer and look at what the people are doing. But also just when you put up mist nets, try and do it in an area where there aren't too many lights around. If there are lights, try and cover them up. Keep your headlamps off for most of the time. So the most common method that we use for mist netting is just called ground netting. And that's just when you've got a mist net that's basically on ground level. And for this then, the consideration is just the location that you place it in. So for the most part, we try and place mist nets close to water. This is just because when bats come in to drink, they fly pretty low, and then you can easily capture them. But we also use stack nets. One thing about mist netting, it's notoriously difficult to take photos of mist nets, and you just actually see the poles. So there's a mist net up here. Ooh, no, sorry, wrong button. There's a mist net up there, but on the sides you can see we've got big poles, and then these ropes are pulley systems. So what we do there is we stack a whole bunch of nets on top of each other, and they're then tied to a pulley system so that we can easily get the net up and down. And this is in general used for bats that fly a bit higher, so the free-tailed bats and those kind of guys, where you need the height to actually capture them. And then another method that we use is called canopy netting, and that's where you chuck a rope over a branch. It works well in forested areas, so you throw ropes over branches, and then you string up the nets between these ropes. This is just, it's easier then to get a bit of height on the nets, and it's also easier to place it in specific gaps. Now again, you can read textbooks and it's going to tell you exactly how you should remove bats from nets. Unfortunately, the bats don't read the textbooks and they don't fly into the nets as the textbooks describe. But what is said is that because they fly head in first and the feet are last to enter the net, is that you try and get the feet out first, then the wings, and then the head. But again, it's not as simple as described. It's, they kind of fly and entangle themselves. So it becomes, every now and again you get a bat that you just open the net and just kind of pops out. But a lot of times they're really entangled in there. And that's where it takes some training. You can also see with these photos, this is actually a free-tailed bat that we captured. They do have teeth. So a lot of people get bitten because they don't stay away from the pointy end. And it's important that you control the bat properly. And this takes practice. It takes training and practice. Then just dismantling nets. So mist nets are not as finicky as people think. It looks like this very delicate little thing, but you can handle them properly. The most important thing is, okay, firstly, when you take down the nets, is to move all debris. So this includes insects, leaves, all those things, because otherwise it's just going to be a nightmare when you put it up again. But when you take it down, put your fingers through the loops on the side. If these loops fall through each other, your whole net becomes entangled, and again, it's a mission to try and fix it again. But then you can, once you've got that right, you fold the net up, disinfect it, and you can pop it back in the bag. So next method is harp trapping. Now, what makes harp trapping very handy is that it's useful in front of caves because it can handle a large number of bats. It's called harp trapping because the strings on the trap is pulled tight, so that it's basically like a harp. And the idea is then that the bats fly into these strings and fall into the collection bag at the bottom. So as I said, it's handy in front of caves when you expect large number of bats coming in. However, you should also just be careful of too many bats being present, because if you've got too many bats, specifically when you're dealing with large bats and small insectivorous bats, they tend to trample each other and you can get deaths in the bag. Also just on this point, now that I mentioned caves, it came up in our discussion group yesterday where people were focused a lot on caves and bats, And it's important to realize that, yes, bats are found in caves, but that's not the only place they're found. And that when you work on bats, don't just consider caves, but focus a bit broader. Okay, and then these are very simple to put up. Basically, roll up the strings and you can disinfect and clean it. The only thing that's important is to make sure that the strings don't go over the sides. Otherwise you get crossovers and then, again, hard to fix. And the last method is hand netting, the easiest method. This is commonly used in caves and such, where you basically go in with a net, hold a net underneath the roosting bats, and they fall into it. The big thing that's important here is to not wave the net around. So you don't want to try and capture flying bats out of the air, because chances are you're going to hit them with the side of the net and break wings, and again, then we end up with severe injuries. So just hold the net underneath the bats, and they'll drop in, and you can start your sampling. Once you've captured the bats, we put them in little cloth bags, like these. We'll show you those tonight as well. And then we just hang them up until they're ready to be processed. Important here is that you've got to consider the weather conditions. Make sure that the bats don't get wet or too cold. So when it's winter, make sure that you just throw a blanket over them, use hot water bottles or something to keep them warm. If you are close to a cave, it's actually very nice, and you just try and hang them inside the cave. So your temperature will be fairly constant inside there, and then you know that they're going to be safe. And then I just quickly added these slides just on measuring. Aura mentioned some measuring yesterday, and I just quickly want to run through the basics of it. So when we measure bats, we look at firstly measurements of certain limbs, and then weight. So to measure the weight, you can either use a spring scale, like this one there, or the soda scales, which is also very handy. You can pop the bat on there in its bag. To measure the limbs, we use calipers. For this, it's important to not use metal calipers, but to always use plastic, because the metal can hurt the wings and so on. So the general measurements that we take, I know if you actually go into taxonomy, there's a whole bunch of others, but we take the forearm. Am I holding this thing wrong? The forearm and then head length. So when I talk about forearm, I just quickly also want to explain something about the bat wing. So if you look at the bat wing, it's basically like a hand, where you've got the thumb at the top and then the other fingers, and then that's your forearm. So that's that part. So yeah, we take the forearm. And then we also determine the sex of the bat and try and estimate the age of the bat. To estimate age, we look at the fusion of the epiphyses. Now, that is the fusion of the bone right there. With sub-adult animals, they tend to be, or the bones aren't completely fused, or the epiphyses aren't completely fused. And when you look at it under light, you see that it is slightly see-through like that. Whereas with older bats, the epiphyses are fused. Now again, this is something that you can describe it all you want, but until you have seen it actually, it's very hard to know what to look for. With certain bats, like the fruit bats we work on, the Egyptian fruit bats, you can actually use the length of the forearm to determine the age. So a forearm length of above 89 millimeters, we consider to be an adult individual. And then we go to marking, or tagging. Now, when animals are marked, it allows for the identification upon recapture. So you actually get recaptured animals. And you can get repeated samples from the same bat, which allows for longitudinal monitoring of viral pathogens in wildlife. And then we can look at the maintenance of these viral pathogens in a population. It also, I remember somebody yesterday mentioned something about marker recapture methods, and it allows you to use marker recapture methods to estimate population sizes and survival of animals in a population, and also just to look at demographics a bit. Now, back in 1943, Cook stated that he gave 7 points for a marking method to be efficient and something that can be used. And he said that it should not injure the fur of the animal or increase mortality rate. It must be permanent, humane. The mark must attract the attention of a researcher. It should be quick and easy to apply, and it must be inexpensive. And I think that last point is important for all of us. Now, for bats, the first method that was used back in 1916 was they basically used birdman. So I think most people know bird rings, which they apply to the wings or hind feet of bats. And these rings were developed as we went on, and they actually made rings for bats specifically. However, thus far, rings has always caused injuries to bats, as can be seen in the one picture there. And even though the injuries aren't always that severe, it leads to infection and very often causes the death of bats. And this led us to start investigating new methods. So 2 other popular methods that used to be used is freeze branding or necklaces. So freeze branding just involves literally branding the animal. And this was also not as effective because the marks tend to disappear after a while or fade and wasn't clear anymore. So they also tried necklaces, which again worked to some success, but on your more agile species, necklaces tend to hurt the animal and affect their flying capabilities. So back in the 1980s then, they started using pit tags. Now pit tags is just a passive integrated transponder. It's basically a barcode. It's called passive because you don't need batteries or anything like that. As I said, it's a barcode that you can scan, and it gives you a unique ID code. And they are commercially available. With these, there's actually also no need to recapture the animal because you get devices, which I'll show in a little bit, which allows you to read this tag without having the bat in hand. The problem again with these is that they are often lost. In a relatively recent publication in 2021, they looked at tag loss. So firstly, they have said that if you just apply a little surgical glue on the spot where you put the tag, so the entry window of the tag, it helps to eliminate or reduce at least tag loss. And then this publication in 2021, they tested tag loss, and they still had a 2.7% tag loss, which is not massive, but your mark recapture methods depend highly on having almost 100% recapture probability, or not probability, but the tag remains. So this still influences it. This is just your general pit tag setup where you've got your pit tags, your reader, and your gun. But again, we're going to show you all of these things tonight, and we're going to put in some pit tags, hopefully you'll capture bats to do this, and then show you the method behind it. So the method used to do this, we use 2 different tags. So for the fruit bats, we use a 12mm tag. For the insectivorous bats, we need an 8mm tag. And these tags are implanted subcutaneously, so just beneath the skin, between the scapular region of the bat. So before we start, we first clean the area thoroughly with 70% ethanol or betadine solution. And then you basically lift the skin of the bat into a little tent and put the needle in there and then apply the tag. So you check that the needle is bevel side down, and then you pop it in and you can apply the tag. Again, this is very oversimplified, and our people who do this have gone through training and been taught how to do this. Again, it's not something that you just go buy pit tags and start pit tagging bats. Please just, it is a very big needle for very small animals, so just always take that into consideration. And then you've just got to be careful that you don't push the needle all the way through so that it goes on the other side of the skin, or that it's not deep enough, because otherwise the tag also just, don't go in underneath the skin. So as I said, there's ways that you can deploy equipment that you don't actually need to recapture the bat. And that's basically these trap arrays. So it's a very long cable that you can suspend in front of a cave or any sort of roost. And this will then pick up the bats as they fly in and out and actually read the tags. The big difference between the 12mm and the 8mm on all the different sizes of the pit tags is just the distance that these kind of trap arrays can pick the tag up. So if you are working on bigger animals, it's always better to implant a slightly bigger tag if possible, because it just allows you to obtain more recaptures as they fly past. Now, a method that we've been using for quite a while is tattooing. So we actually place tattoos on the animals. And this has been used since the 1930s on mice. And it's still a very popular method of marking animals, but more so in a laboratory setting. For bats, they've used various methods of tattooing, varying from needles, which was also, I think, used in the 1930s, where they actually used just plain needles, which they dipped in ink and then placed tattoos with. This method was described as cumbersome and taking long, and so they never really continued with it. But they also used wing punches, which is basically right here, where you basically punch numbers into the wing that's been dipped in ink. And then this places a number. Problem with this is that because it's just tiny little holes, it grows over and the mark is not always permanent, and you lose a lot of the marks. We have found, however, that tattooing is a very effective method, especially when you're doing a large number of bats, because it's very cost effective. It is quick and easy, it's humane, and it's very long lasting. And when I say long lasting, we've had a bat that we've recaptured after 7 years, and the tattoo was still there, still legible. We've also used this method on a captive colony, and all the marks remained legible for the entire period, and all the bats were not injured and alive at the end of the study. So this is the basic tattoo setup, where you're sitting with a power source, so fancy word for a battery, that we connect to the power supply. So all your tattoo equipment then plugs into this, and that's then where you control the speed of the needle and everything. I'm not going to go into too much depth about this, but you've got your needles there, and then your tattoo gun over there, and then this is just the board that we place the bat on when we tattoo them. And then this is basically what it looks like. So for fruit bats, we use a combination of 2 letters and 3 numbers to mark the bats. For insectivorous bats, it's not very clear. We use 1 number and 2 letters just because the wing is much smaller. And then how it basically works is it's always in a 2-person team. The one person holds the bat and makes sure that the wing is tight, and where the tattooist then holds the other side of the wing and places the tattoo. When we do this, we first clean the wing with tissue oil, or you get products for this as well from AIMS, which is the Animal Identification Marking System. So you can have a look on their website. They supply a whole bunch of equipment for this. But we've actually found that normal tissue oil works great. It actually works better than the AIMS oils. And we've been working with that now for quite a while and found it very useful. So your power supply, you always set to maximum voltage because this controls the speed at which the needle moves up and down. We found that the needle moves a bit quicker, the tattoo doesn't hook on the wing as much, so you get a nice clean tattoo. So you basically load the gun by dipping the point in some ink and then depressing your foot pedal, and this then loads the gun. And then we hold the needle above the wing, but not on top of the wing. So it's got to be like literally a millimeter above the wing, and that's in how we apply it. Also, hold the needle nice and perpendicular to the wing. It also just helps with applying the tattoo. And that brings us then to the last T, to tracking. So tracking is there to monitor movement and migration patterns. So short-term movement, so this is just the general foraging at night, and then migration. So this involves longer stretches. And for this, we basically get, again, 2 types. Very broadly speaking, 2 types. You get VHF, which is very high frequency trackers, and then GPS, which everybody knows GPS trackers. So just on the VHF tracking, master student Matthew, who's at the back there, he's actually been doing a project on this. So I'm not going to go into a lot of detail about his project. Matthew, there's Matthew, the skinny, tall one. If you're interested, you can talk to him a bit about his project, and he'll gladly explain a bit more. But we basically got trackers from Hollowwheel, which is a company in Canada, and that's these little trackers that we then placed on the fruit bats. They've got a collar that's designed to fall off after between 6 and 8 months, so the tracker naturally falls off. And each of these we then calibrated, so which just means that we went out and tested each of them to see what your signal strength is per tracker at a certain distance. And then we located the bats with a Yagi, or a directional antenna, and we could get a direction to the animal, and based on the signal strength, we could get an estimate of distance. And this then allowed us to plot exactly where these animals were. These tags are also very cool because they tell you if the bat is flying or resting. So depending on the frequency, well, not the frequency, but the beeps it sends out, you can actually determine the bat is flying or stationary, which is also just nice. You can determine sort of the behavior. Anyway, we all plotted this then in QGIS, and this then allowed us to look for overlap of these bats with humans and wildlife. As for GPS trackers, so these are a lot more expensive than VHF trackers. Again, broadly, you get 2 types. You get satellites and download. Satellite tags are just basically it transmits directly to a device. So it connects to a satellite and connects you or sends your data directly to you. Whereas download tags, you have to either get the tag back and download the data from the tag, or you can download it via VHF. Now, with all tags, VHF and GPS, a consideration is the size of the bat you're working with. Ethically, we can't put a tag that weighs more than 5% of the animal's body weight onto an animal. And that's where GPS tags becomes a problem, because they tend to be bigger. the size of the tags are highly dependent on the battery that's needed to power them. And the more advanced your tag is, the more advanced your tag is, the larger is the battery. So in general, you do get very small GPS tags, but then your battery is very small, which means the tags don't last as long. However, with certain bats, such as certain fruit bats, you can actually deploy solar tags on them. So this means that this tag, because they roost outside in trees, these tags are actually constantly charged. So you can go for a smaller tag that lasts longer, and then it becomes very effective. So they have deployed GPS tags on rosettas, on the Egyptian fruit bats before, but they don't last long. You're looking at about 10 days worth of data. Also, you need to get the tag back to actually get the data back. So if you put one of these, because they are very expensive, put these on a bat and they decide to migrate, you're probably never going to get this tag back and all your data is lost. Now there's been some talk or some mention again of echolocation calls and how we use them. I also just quickly wanted to mention it. So echolocation calls, just again, broadly speaking, is basically the sound that bats make to help them navigate their way around the world. And this is more for insectivorous bats. You do get a few fruit bats that's got rudimentary echolocation, but it's more for insectivorous bats. Now you get, according to me, you basically get two types of echolocation recording, if you will. The first is for processing, where we construct call libraries. Now, echolocation calls are relatively unique to specific species, but there is some overlap between species. And you also will find that the same species will have slightly different echolocation calls in different areas. And because of this, we construct call libraries. Now, this basically means that when you've got a bat in hand, you try and record its call, and then you can use that by placing then static recorders out. You can actually record more calls and determine sort of abundance in an area. Yeah, so you get the two types. This one is more for like active monitoring, where you can hold it in hand and actually see the bat being recorded. We've got one of these that we'll show you tonight as well. And then you've got these that's more to place out on a semi-permanent basis, where you can deploy these type of bat detectors and set them to record from a specific time to a specific time. Let's set a whole bunch of variables. And then this will record every single night for as long as you have them out there. These are deployed on we just call them masts, so about 9 meters in the air. You pop the microphone, and then your bat detector sits a bit lower down, so you've got a 5 meter cable for the microphone, and then you can place these wherever. So important when you do this is, again, to just consider the habitat and try and monitor as many different types of habitats, so that you next to water or next to vegetation, or so that you can get an idea of the species activity in the area. Then we get to camera trapping. So this is something that we've been using to monitor overlap between just wildlife and livestock in areas. So we've been, in one of our study sites, we've been placing camera traps out across quite a large area. And this then allows us to, like I said, monitor the area, the frequency of use, and so on. So we've got one that's just outside the cave that we work in to kind of look at what other animals are using this cave. So we know that there's at least 2 porcupines that live inside the cave and come in and out every single night. We've got a genet that also comes in and out every now and again. And then we've had monkeys go past and dogs go past. And then we've had people go past. So we can also see when people enter the cave, how often. Obviously we can't see what they're doing inside the cave, but we at least have an idea of how frequently the cave is used. Can I play the video here, please? This is just a little video of the bats flying out of the cave. So with rosettas, it's actually very nice. Because rosettas have got such large eyes, you can actually see the eyes fly past. It's a very short video. And it's just a little interesting video to show how you can also see when bats fly past. This doesn't work on all bats, though. I suppose with more modern camera traps, it might be possible to actually pick up a bit more information. Then we also look at species overlap. So we put these in specific spots. So this one was next to a river. Not all the very small photos, but we've got antelope and porcupines and jackal, monkeys, water mongoose, bush babies, genets that walk past this. And we can also pick up livestock that moves past. And just see where there is overlap between livestock and wildlife in an area. You can also look at species diversity. But when you do this, it's more with traps that are baited. So you actually place bait in front of the trap, and you can sort of draw in animals and look at what is in the area. And then again, we get a lot of stuff. So genets, jackals, monkeys, baboons, there's a little daker. And again, you get the livestock coming past, not always towards bait, but just walking past. And again, some people who interact a bit more with the camera. And then lastly, we go on to climate data. So I just quickly wanted to mention something about this. So when we monitor climate inside a cave, we normally use eye buttons, which are these little things at the bottom. And they then record temperature and humidity. So you set them to record temperature and humidity the way you want. So, and then depending on the frequency that they record, that determines how long they last. The lifespan is not actually dependent on the battery. The battery will go on for a few years. It's more on the amount of data that can be stored. So we put these inside caves. Important about these is that they're not actually waterproof. So a lot of people do put them or seal them in wax, but when you do this, you need to calibrate them again. So just pop them in a water bath and see that if the water bath is at 25 degrees Celsius, at what temperature do they then pick up? And then for general weather in an area, we've got a weather station. And this then measures everything. So you've got wind, and it measures rain, temperature, everything. There's also solar powered, so it'll go on for as long as you want. And all the data is then sent to this little device that stores it until you go and download it. Problem again is that these things are pretty expensive, and if you're not working in an area for a very long period, that's no real point putting this up. So in those cases, to get weather data, I know in South Africa it's fairly easy. We can contact the local weather bureau. Based on our discussion groups yesterday, I think the people from Zimbabwe can also just contact the weather bureau and they can get the data. If it's not that simple in your country, there are a few websites that can be used where you can actually get data from. And one of the ones that I like to use is yr.no. And this is also a site that I use to look at weather for a specific area. So this is just quickly something that I pulled off. So this is for Pretoria. We're in for a good mist netting night, it seems like. So it's not too cold tonight, and we've got some cloud cover to cover the moon, so we're good. Wind seems good. And you can actually request data from them. Again, there are some forms you need to fill in, just why you need this data and so on. With all of these sites, so with any website and actually getting data from the Weather Bureau, it's important to realize that it's not going to be very specific to your site because they use the closest weather station available. So if you really want very accurate data, it's more important to use a weather station. I mean, you can even use just eye buttons if you're just interested in temperature and humidity. So you can use those just to monitor. But if you're interested in really accurate data, we would suggest going for a weather station and monitoring the weather in that way. Thank you very much for your time.